When your coding agent screws up, the wrong answer is not always the biggest problem. More dangerous is an agent that finds the right doors open. ENV files, local sockets, remote control channels, persistent tokens, and shell tools without clear boundaries. This episode gives you a simple security checklist. It lets you use agents productively without handing over your entire system. Why does this matter now? Agents no longer run only as a single chat beside the editor. Modern coding agents are moving toward background runs, fan out across many sub-agents, remote runtimes, and tool execution. Current release notes across the agent ecosystem show what matters operationally. They highlight better data exfiltration detection, stricter rules for risky paths, short-lived server tokens, socket bans, and more visible tool states. This is not an abstract security debate. It is everyday reality. Once an agent does not just answer but acts, the failure pattern usually looks harmless. The agent is supposed to fix tests but also reads configurations on the side. It should start a local server but gets access to sockets unrelated to the task. It should use a tool, but nobody checks whether it may write, delete, upload, or open network connections. And when something goes wrong afterward, the crucial thing is often missing, a traceable record of which run had which access. The solution starts with env. Treat every env file as if it were a production keyring. It does not automatically belong in the agent context. Create separate example files, work with dummy values, and give the agent only the variables it needs for that specific run. If a tool absolutely needs real credentials, do not keep them as permanent secrets in the project folder. Use a controlled secret mechanism instead. The second point is short-lived tokens. Permanent keys are convenient, but they make agent mistakes long-lived. Better, one token per run, with a narrow scope and an expiration time. If an agent goes off course, the damage remains limited. Access does not stay valid forever and has no more permissions than necessary. Third, socket policies. Local sockets and ports seem internal, but they are often controlled channels. Whoever can write there can, in the worst case, trigger more than a normal API call. That is why Unix sockets, remote control endpoints, and local admin ports should default to deny until a specific use case needs them. Fourth, tool checks. An agent is only as safe as the tools it can run without asking. Split tools into reading, writing, network, shell, and destructive action. Reading can often run automatically. Writing needs context. Deleting, deploying, pushing, and database changes need a review gate. Fifth, logs instead of gut feeling. Every agent run needs a run ID, a list of allowed tools, visible tool calls, and an outcome log. This matters even more with several agents in the background. Otherwise, you no longer know which superscosts made which decision. So the checklist is short. Keep env out of the context, make tokens short-lived, block sockets, separate tools by risk, log tool calls, and never automatically approve destructive steps. Then agent security stops being a break and becomes an operating model. If you remember only one sentence, the agent does not need to be perfect when its access is limited, short-lived, and verifiable. Save this video so you do not forget.